Hello students, so today we will discuss about some artificially made materials which show some unusual properties. We'll first start with something called a negative refraction. If you look into the picture, you can see that the difference between these two pictures is this is where a negative diffraction is occurring. The You can see how the object which was visible to be in one direction suddenly changed to another direction when this material was changed. So basically what is happening is a violation of Snell's law is taking place, and the light bends in the opposite direction. So according to the Snell's law, n1 sine theta 1 is equal to n sine theta 2, which indicates the two refractive indices, and when the light is traveling from one medium to another medium, it shows a change in direction. And if the second medium is denser medium, it will also show a change in phase. Now this is the original Snell's law, but in the material having negative refraction, having properties of negative refraction, what will happen, this ray, as you can see, instead of going in this direction, has moved in totally opposite direction. So it indicates that the angle which we were calculating from the normal, in these cases we were calculating the angle from the conventional anti-clockwise direction, but however in this case we need to calculate the second angle by clockwise direction. So that is what is this, the angle is getting reversed, so that's how this negative sign is coming into this equation, and also we are getting these sort of defects, these sort of effects. Now these materials which show such type of negative refraction, they are called metamaterials. Now metamaterials, apart from negative refraction, they also show negative permeability and also the negative permittivity. Now since these three terms are related to each other, like n is equal to root over epsilon mu, so this is what makes an artificially engineered metamaterial. Other properties of metamaterials are the phase velocity increases, and also the evanescent waves that decay very with respect to distance, and these are found in the optical fibers where the total internal reflection is taking place. So these waves decay, these waves enhanced, they do not decay so rapidly. Now, so here is how the artificially made metamaterials are different. So if you compare an opaque material, which is from a transparent material, the thing that differentiates an opaque material is a transparent material is, apart from the permeability, it shows an opposite sign of permittivity, and also the refractive index is a constant here for opaque materials, however it is more than 0. For magnetic materials also this is a constant. Magnetic opaque materials, the permittivity is 0 and epsilon is 0. In the transparent but different type of materials like metamaterials, these are the following things that are found, or that are deliberately made such that these properties they can be found. Now, as in normal material which is made up of atoms, metamaterials are made up of units which are actually being engineered. Like here you can see this is a unit of a two-dimensional array of material of a different refractive index, and the reflectance study on these sort of materials show two peaks, and the reflectance study is also done in two modes: transverse electric and transverse magnetic modes. So one peak which is common to both of these modes is the plasmon peak, and this is due to surface plasmons at the metal and dielectric interface. The second peak, called the LC peak, it is called the left-handed circularly polarized peak, LC, and it mainly is found in the case of transverse electric mode. This is mainly because of the fact that for an LC circularly polarized field peak to be observed, the electric vector should be propagating along the propagation vector, and if it is not, then will be no LC peak. Now another type of as we have seen that the metamaterials, instead of atoms, they have units. One of those units is called split ring resonator. So it is basically a concentric ring, or two metals with a gap in between, and deposited on a substrate which is a dielectric. And this structure, it produces electric field, and there is a resonance occurring at a frequency which is equal to 1 by 2 by LC, where C is the capacitance of these two diodes, and this is where is the inductance at the dielectric, as if it is surrounding the dielectric. Now again, this resonant capacitance, what it does, it enhances, or sorry, the capacitance, it enhances the resonance, and the resonance and inductance again is related to the dimension of the structure, like mu 0 r square divided by d, the distance between the plates, plus the crystal substrate width. This is what makes the inductance. And where r is the ring radius, it can be in it is showing in a straight form, but it is also circular in nature, like this, where there is a gap and there is formation of reverse current here. Now the inductance is related to the dimensions of the tube, dimensions of the system, and so is the capacitance. Now there are different types of metamaterials. Like in terms of electromagnetic aspect, we can have single ring, slit ring resonator that we have just explained, which is showing these sort of properties, which is used in MRI and optical clock system. Then we have complementary SRR, then metal dielectric metal structure, and complementary SRR used in electromagnetic shields antennas. There are other non-linear crystals like lithium, niobium oxide, and KTP, which show a property called MW, which is the mass, metal density, and metal dielectric metal contact structure, and it is used in optical sensing as well as in optical non-linear optics. What is a non-linear optics? Non-linear optics is nothing but the optical properties when changed with the intensity of light. This is known as non-linear optics. So there are certain equations related to non-linear optics. V is equal to epsilon chi E, and these are the two components of refractive index, and there is a harmonic generation still existing. Now this is optical electromagnetic metamaterials. Then we can have electrical metamaterial. Then we can have optical metamaterials as well, which consists of plasmonic metamaterials, photonic metamaterials, and helical metamaterials. Then we can have acoustic metamaterials, and they are accompanied by negative phononic crystal, negative diffraction coefficient, again photonic crystal. Then we can have thermal metallic materials like thermal clocks with the negative thermal conductance, and so on and so forth. And they can have phonon based material. Mechanical based material consists of oxidative cutting system. Then mechanical metamaterial have again this negative stiffness, this which is unusual. And then we have shape memory metamaterial. Now this acoustic metamaterial, if we look closely, this acoustic metamaterial can be controlled by the transmission and the reflection coefficient. And mechanical metamaterial, the deformation again can be controlled. And the photonic metamaterial is where we have this negative refractive index, and this negative refractive index is the phase shift. There will be a phase shift in the change with the change in medium. Now, if we assume that this acoustic material, there is a continuous phase shift. So if we denote the phase shift by phi, the continuous phase shift will be denoted by d phi by dx. And considering the fact that there is a negative refractive index, the refractive index can be generalized in this format. And as previously told, it is showing a 2D, it is basically the optical, the negative ones which show negative refractive index, they have nothing but two-dimensional area optical resonators. What is actually happening which is causing this negative refractive index? From here, suppose there is an acoustic wave which is continuously getting reflected from the walls. This is the design which has been made to create a negative refractive index. So as the coil, it is a space coil, and it is also called a metasurface, simply because of the fact that even if the physical path, the path length is not changed by putting plates, what we have done, we have increased the optical path length, and so it goes continuously. It is getting reflected from the walls, and the phase that is being created is phi, and there is a shift that is KL. Okay, so this is how for the first introductory class on metamaterials. We will take up each and every aspect in details in our coming classes.